Okay, so in this video, I am going to share to you the solution of one of the problems that I gave in my exam in one of my subjects. Here is the problem. The steel bars AB and BC are pinned at each end and support the load of 300 kilonewtons as shown. The allowable tensile stress is 100 megapascal and the allowable compressive stress is 60 megapascal. Determine the size of each bar and also the horizontal and vertical components of displacement of point B. So, ma-displacing point B. For sure, it's gone downward now because of the direction of the force. Take E, the modulus of elasticity equal to 200 gigapascal, and also neglect any possibility of lateral buckling of the bar. So the bar will remain straight. So first step is to determine the forces in the bar. Determine the force of bar AB and also for bar BC because the stress is already given. And we are going to determine the size of each bar. So we need to have the value of the forces of or the force of each bar. Okay. So what we will do is instead of resolving this force A, B, and BC into horizontal and vertical components, much better if um, we reorient the axis. So ato i-reorient ang axis, we will make this one as our local x-axis and this one as our local y-axis. Para ang i-resolve nato is the 300 kilonewton force. Dili na i-resolve ang force sa BC and force sa AB. So, local X and local Y. So, extend na to 60 degrees man 60 degrees ano siya. So, we can get the components of the 300 kilonewton force. So, for this local na IX component, adjacent man, so it's 300 cosine 60. That's 150 kilonewtons. And for this Y component, no, local Y na component is 300 sine 60. That's 259.8 kilonewtons. So by inspection and for equilibrium condition, ang resist aning 150 is this force. So going this way man, so i-resist siya upward. No? First quadrant. And considering the effect of this force on point B, compressive siya, kaya iyang giduot nun. So compression is nga force, 150. So, para equilibrium, dapat equal og magnitude sila duha. Similarly, sa member EB, the force of EB will resist this force 259.8 pero downward man na siya to the right, i-resist siya o upward to the left or second quadrant na direction. Same magnitude. And considering the effect of this force sa point B, tensile siya. Kaya away sa joint. So tensile na siya. Ang unit siya ni kilonewtons. So with this, we can now determine the size of each bar. So we are going to solve for the size of the bars. We're going to use the formula. Stress is force over area. So let's start with bar EB. This is the formula. Stress equal to force over area. Now, since ang unit is in SI, always remember na sa SI, ang stress na to will be expressed in megapascal. And ang force is in newtons. Ang area is in millimeter square. Because we all know that 1 megapascal is 1 Newton per millimeter square. Okay. Let us substitute the values. Stress for EB. Tension man eh. So allowable tensile stress is 100. Megapascal na, so 100 lang. Ang F dayon, 259.8 pero kilonewtons man eh. Kilonewtons. So i-multiply na to o 1,000 conversion factor. Para man-newtons. And then our area, circular, pi over 4d squared. This one. So ang 1,000 here is conversion factor from kilonewtons to newtons. And cross multiply, you transfer d square sa left side sa equation and then you transfer 100 sa denominator sa right side. Cross multiplication. Like this one. So ang next ani is i-compute using your calculator, i-compute, and then after that, you get the square root na kay D. So the diameter of bar EB is 57.5. Minimum. Okay, so dili pwede na smaller than this. Or else ang stress niya will exceed 100 megapascal. So, next, for BC, same formula sa BC pero kay compression man eh. And the allowable compressive stress is 60. So 60, ang force is 150. And then conversion factor from kilonewtons to newtons at tapos area. And same sa EB, cross multiply. Compute, and then after that you get the square root. Then this 56.42 millimeters. Okay, so we are done with the size of each bar. Next is to determine the horizontal and vertical components of displacement of point B. So para makuha na to ang horizontal and vertical displacement, we need to solve for the deformation of the bars. Okay. So let us solve for the deformation of the bars. The formula to be used is this one. PL delta, the deformation is PL over AE. But we can change P over A by sigma. Okay, P over A, or this one, force over area is stress man. So force over area can be replaced by stress. So the expression of delta becomes this one. Stress times L over A. L is the length of the bar. So for member BC, the length is 3, but for member EB, unknown pa, so we still have to solve for the length of EB. Okay. So, to solve for the length of EB, with known values BC and 60, we can use trigonometry. Tangent of 60, opposite over adjacent. So we have this one. Tangent 60, length of EB over 3. And you cross multiply. Length of EB is equal to 3 tangent 60, and it is equal to 3 square root of 3 meters. Okay, so we are now ready to solve for the deformation. Okay. For EB, use this formula, no? Sigma, 100 man. Kay ang EB kay tension man eh. So we will use tensile stress. 100 length dayon. Now, the unit of stress and E can be cancelled out. The unit of stress is megapascal. The unit of E, gigapascal. This can be converted to megapascal. So makancel ang unit sa sigma and E. So what remains is the unit of L. So the unit of delta is the same as the unit of L. So if you want the unit of delta to be millimeters, dapat ang unit sa length na to millimeters po. So this is why natay 1,000 kay 100 is megapascal. E is 200. Nagmultiply tag 1,000. Conversion from gigapascal to megapascal. Nagmultiply tag 1,000. This one is the length. 3 square root of 3 pero meters man. So multiply tag 1,000. Conversion factor from meters to millimeters. So ang unit na yon is millimeters na. Kaya ang unit sa 100 and ang unit sa 200,000 na-cancel man, megapascal. So, millimeters. Mas realistic eh. Mas dali naka-relate kung 2.598 kaysa 0.002598 meters. Okay. And this is elongation, kaya tensile man. Increase in length. For BC, same formula. Stress 60, length 3 meters. The deformation is this one. Stress, length, conversion from meters to millimeters, and then modulus of elasticity. The deformation is 0.9. Negative, shortening. Kay compressive man ang force. So we are now ready to determine the horizontal and vertical displacement of point B. Okay, i-plot na to. So this is point B and this is member EB and member BC. Okay. First is i-allow na to na mo expand nila. May-elongate ni EB. May-elongate siya by this amount, 2.598. Therefore, ang point, considering member EB, ang endpoint sa member EB is there is a B. So, kung ma-elongate siya by this amount, point B will now be transferred to another location, somewhere here, like this one. Ma-elongate na, okay. Mauna niya ang bago na location sa B. Considering member EB, so let us denote this one as B prime. Na siya change in length na 2.598. Okay. Now, in the case of BC, kay compression man shortening siya. So, point B for member BC is ma-shift siya dire, ma-transfer siya dire nga point. Kay shortening man. Like this one. Okay, so kini na point B, consider member BC will now be transferred to this point. Let us denote as B double prime. And this distance is 0.9. 0.9. Okay. So, what is really the final position of B? Okay, so kung mabalik tayo dire, because of this load, 300 kilonewtons, and consider member AB, muswing siya paingon dire. Muswing siya clockwise. Okay? And also for member BC, and considering this force, pag-apply niya, kining member BC, muswing po siya dire. Clockwise. Bale, ma-rotate siya ba clockwise. Ang EB, ma-rotate po siya clockwise. So, kung i-apply na nato dire, kini na member, ma-rotate siya clockwise, and kining member EB, ma-rotate po siya clockwise. So, the direction is perpendicular siya. Mo-move ni dire, perpendicular, mag-draw kag line na perpendicular da. And also for this member, mag-draw siya perpendicular na line. the point of intersection is the final position of B, like this one. So this is the final position of B. Perpendicular niya, perpendicular. So mo ni ang final position sa B. This is the initial position. So we can get the distance of this para we can construct a triangle. Now, let us denote this one as B triple prime. Mo ni ang distance from initial to final position. So kung ato siyang i-separate, atong i-blow up gamay, initial position and final position. So if we draw a triangle, then this is the horizontal displacement of B. And the difference in Y value is the vertical displacement of B. So final position, initial position. Okay. So in order to solve for X sub B and Y sub B, we need the distance B triple prime and also this angle. Okay. So para makuha ito yung angle, kuha ko sa natuunan eh. Theta. And first distance BB prime, we can get this one, this distance using Pythagorean theorem. So okay, square root of this one value, this value squared plus 0.9 squared. So the distance of B triple prime is 2.75 millimeters. And to solve for theta, arctangent or tangent theta opposite, this one opposite 0.9 over adjacent. So theta is equal to arctan of 0.9 over 2.598. And the value is 19.11. Oh, okay. So with this one, we can now get the angle of this line with respect sa vertical. So kung mag-draw tag vertical line, remember that this is 60 degrees. Same raman na dire, 60 degrees. Okay, 60 man eh. So 60 siya na. So this one is 60 degrees. And if you denote this one as alpha, ma-solve na to ang alpha. Kaya 90 man eh. 60. So therefore, 30 na eh, no? Tama diya, 30. 30 minus theta is equal to alpha. Or simply, alpha plus theta equals 30. So alpha is 30 minus theta. Substitute ang value sa theta, natay alpha na 10.89. So kung ito i-transfer na dire, the length of B triple prime is 2.75 and this angle alpha. So by trigonometry, we can solve for X sub B. Opposite sa angle, so sine ta. XB is equal to hypotenuse sine of angle. And compute the answer is this one. To the right. Bale, ang final position with respect sa initial position is right and displacement to the right. YB, adjacent siya. So cosine. Hypotenuse cosine sa angle. Hypotenuse times cosine of the angle. 2.7 millimeters downward because the final position is lower than the initial position. So this is the answer of this problem. Size of bars, EB and BC, horizontal and vertical displacement of B. Thank you for watching. I hope that you have learned something from this video.